Hi, I'm Lisa Buscher. I'm part of the team of TLK-Thermo. We offer engineering services and software for thermal systems. We work in the fields of simulation, measurement, and software development. Today, I want to show you our web tool of a hydrogen refueling station, which we developed together with the Institute of Thermodynamics of the TU Braunschweig in course of a research and development project called TEVA, Thermal Management of Hydrogen Refueling Stations. This project is funded by the Ministry of Science and Culture of Lower Saxony. Here you already see our web tool. The website is hosted by our partner company TLK Energy. You can easily register for free by just entering your email address and setting a password. On the right side, you see the system model that is underlying this web tool. The system model is based on our software package TIL Suite, which includes the model library TIL for thermal components and systems using the modeling language Modelica, and the material data library TIL Media, as well as the add-on Hydrogen Energy Systems, which contains specific component and system models for hydrogen applications. The system model allows the transient and dynamic simulation of back-to-back vehicle storage system refuelings with compressed gaseous hydrogen via cascading buffer banks of the hydrogen refueling station. The hydrogen is stored in compressed gaseous form at the refueling station and in the vehicle. First, I want to show you all the different components that are considered in the system model. First, we have the main storage of the refueling station, which is modeled as a volume with constant pressure and temperature. For each of these components that I will show in the following, you see on the left side the input parameter GUI, where you can set the most relevant parameters for your specific simulation. Beside the supply storage of the refueling station, the station considers a hydrogen compressor to refill the buffer banks after refueling or during refueling. The model of the hydrogen compressor is based on an isentropic two-stage compression with inter and after cooling to ambient plus 15 Kelvin. Then we have different buffer banks that can be considered. You can choose between a number of 1 to 5 different buffer banks. For each buffer bank, you can parametricize the specific number of pressure vessels, as well as the nominal working pressure per buffer bank, and the geometric dimensions of the pressure vessels, as well as the material data of the vessel walls, liner, and wrapping. For the hydrogen refueling, it's also necessary to pre-cool the hydrogen. Therefore, we have considered a simplified pre-cooling unit, which is based on a relative cycle efficiency with respect to the ideal Carnot efficiency. The refueling station contains also a refueling assembly. Here you can set the flow coefficient of the nozzle as well as the dimensions of the hose. Next to the refueling stations, we also have the system set up for the vehicle storage system. The vehicle storage system considers a variable number of identical parallel pressure vessels that are refueled simultaneously. Here you can also specify the pressure vessels with the nominal working pressure, as well as the number of pressure vessels, and as I mentioned, the vessel dimensions and vessel material data. In addition, we consider pressure losses by parametricizing different valves and tubings. Beside the component parameters, you can make some decisions regarding the refueling station control, for example by setting the ambient temperature and the control parameter, the average pressure ramp rate, which is set at the control valve to regulate the vehicle refuelings. In addition, you can set the number of vehicles that should be refueled back to back, and you can decide when a vehicle refueling should be stopped by setting a target pressure or target state of charge. Between two vehicle refuelings, you can set the handling time. In addition, you can set the initial conditions which will be considered at each start of a vehicle refueling by setting the initial temperature and pressure of a vehicle storage system. Last but not least, you can decide when the simulation should be stopped, and you can choose an output interval for the results. In the next video, I will show you all the results that can be generated using our web tool for a hydrogen refueling station. The link to this web tool, as well as links to all the software tools I mentioned in this video, can be found in the description of the video.